Morning, afternoon, or evening. Okay, so today in day 4, we're still looking at integration, and we're going to add in the more complex parts of integration now with still using indefinite integrals. And that is called the substitution or chain rule with integration. So we're going to look at that technique today, how we use it, and what are the steps that we follow to complete the chain rule or substitution rule, as I like to call it, and use that with combination of what we've learned already with the power rule to do some examples and then practice for tomorrow. So today will probably be a fairly long video, about 35 minutes or so, as I do have various different kinds of examples that I want to go through with you. Okay, so we are going to be using the chain rule. So what is the chain rule basically? Well, let me basically state it here for you, and then we'll kind of go through step by step an example and how we would use the chain rule with integration. So if you're going to integrate something that is, say, a function f of x, and and it has f of x dx here. Okay, so there's kind of a chain of two functions in there like that. We still have that where we're doing, f of x n plus 1, whatever that power is, over n plus 1. So that's still the power rule plus c. Okay, so we're still using the power rule. And what we're going to do is we're going to do an example of using the chain rule here. Give me a minute here. I'm going to check these messages I've got here. I'll just pause and I'll be right back. Okay, so back here again, I'm just going to do step by step. There's basically a 5-step process that you would use to complete doing a substitution integral here. Yeah. So let's go ahead and go through that. Let's go through a simple example here. Let me see what I got here. All right, let's say we have something like let's title this first. Let's say steps involved or to follow. Okay, so now let's say we take the integral of 3 plus 2x squared to the power of 3 at 4x dx. Now sometimes the 4x is put out front. Sometimes it's put it over here. It doesn't matter. So we can't really just integrate that like we normally would. So the first step that we got to do is we got to take and this process, by the way, I should mention, doesn't work for every single case. You have to have it has to kind of be set up correctly. So it's not a perfect method for everything. It doesn't work for everything, obviously. It's just for certain types of integrals, just like the other rules when we had derivatives for a certain type of function that we're doing. Okay, so the first thing that you've got to do is you've got to use a variable substitution. So step 1 is to basically define a variable u, we'll say, equals, and we usually do the brackets here, 3x, or 3, plus 2x squared. Okay. Step 2 then, after you've got the variable there is to find du. Okay, so we find du. Okay, so we're going to write it in fraction form here. We want dy or du dx, sorry, not y because it's a u, du dx. So we're going to be taking the derivative of this function here is equal to 0 plus 4x. You can see where we get the 4x from, right? Okay, and then we have to rearrange this so that we can get an answer for this one. So du multiply both sides by dx equals 4x dx. Okay, so we found out what du is. Now in step 3, we have to basically make sure that it fits into here. So these ones are actually matching. Sometimes they won't match. Sometimes you have to multiply or divide by a constant, which I'll show you in other examples. But right now they match up, so we're good. So then our next step is to write the equation in terms of u. Okay, so if I were to do that, we notice that this is du. So this whole thing is du here. And this is u. So it'd be u to the third du. Because 4x dx is 1 du, according to this substitution derivative that we did. So let's rewrite the equation. U cubed du. Now that we can do the derivative, or sorry, we can integrate now. So step 4 is to integrate. Okay, so I'm going to integrate now. So I'm going to integrate. We have to add 1 to that, right? And then divide by that number. So this is going to equal y equals, obviously, because we're changing it back to f of x or y or whatever you want to call it. So this is going to be u to the 4th over 4 plus c. Okay, and then the last step is to convert everything back to x in step 5. Convert back to x term. Okay, so we just put in this for u. So we got y equals 3 plus 2x squared to the 4th power divided by 4 plus c. And we're done. Okay, so our steps are to find the variable, take the derivative of the variable and solve for du, rewrite the equation in terms of u. Sometimes we all have to do some manipulation. We didn't in that case because it worked out perfectly. Do the integration and then convert back to where we were. Okay, so we'll do 4 or 5 more examples here that use different kinds of special, well, I guess not tricks, but converting and making sure that you get the proper du and things like that. Okay, so I'll show you a few different examples, some with roots, some with extra powers, some with different various numbers in them and things like that. So let's go ahead and do that here in our next little bit. So we'll go through a bunch of examples here. Again, I'm going to just pause quickly and get my example sheet out. Okay, so my first example, I'm going to title it here. And this is going to be an example where some manipulation is needed. Of the equation is needed. Okay, so this means you're going to do multiply by a constant or divide by a constant, something like that. Okay, and this is for our second example. So the one I have here is if we have an x, I'll put the x squared out front this time so you can see that it doesn't matter where it ends up. 2x cubed minus 4 to the power of 4 dx. Okay, so our first step is to write u for this bracketed term. U equals 2x cubed minus 4. Okay, then we find du. So du dx is equal to 6x squared and then minus 4. And then we rearrange it. So du is equal to 6x squared, dx. Okay, that is not x squared. That is 6x squared. So in order to make this x squared, how do we get this to be x squared dx? So we're going to have to do a manipulation, and we have a simple manipulation. We want x squared dx, not 6x squared. So how do you change like 6x squared to x squared? We divide by 6 on both sides. So that's what we're going to do. So we are going to find x squared dx is what we want to find. So we're going to divide by 6 on both sides. So if I divide by 6 on both sides, I end up getting du over 6, or 1/6 du, equals x squared dx. So lo and behold, we do now have that part of it. So now when we are going to substitute into the equation, we have this part. Instead of putting in du, we put in du over 6. Okay, so what does that look like? Okay, let's do our substitution. Okay, so we have this represents u to the power of 4. This is represented, the red, underlined red part is represented by du divided by 6. Okay, now we want to get this common number out so we can bring it out front. Okay, because this is all multiplying inside. So if we bring it out front, if we bring a divide by 6 out front, it's like 1 over 6 or 1/6, right? So we can write this then as 1/6 the integral of u to the 4th du. And there we have something we can integrate now. Okay, so we've gone to the point now we've gotten to the point now where we can use the power rule for integration. Okay, so let's go ahead, leave the 1/6 out front, and we've got u to the 5th over 5, and there is what y would be. Okay, so if we were to do that, okay, we can multiply this out. It'd be u to the 5th over 30 plus c. Okay, there's our answer in terms of u. That's not what we want. I guess I should put the y in there, y equals, sorry. Okay, what we want is it in terms of x, so we have to go back here and plug this in to where we see the u. So this y our final one would be 2x cubed minus 4 to the power of 5 over 30 plus c. Oops, over 30 plus c. Now you could write it as 1/30th out front if you like. Some books will write the answer for you like this. Okay, but this is a good answer too. There's an example of doing an example of some manipulation needed in order to get our substitution integral to work out to something where we can use the power rule right here, pardon me, when we had it in this side and we brought it like here. Okay, so let's do another example with manipulation. A couple of these, a little more complex one. Let's do one that's got some multiplication rather than division in it. And then we'll do one that has some roots in it as well. Okay, so this will be example 3. Some manipulation still. This time we're going to use is going to be a multiply example. Okay, so instead of dividing, we're ending up going to multiply. Okay, so my example for that is this one here. If we take integral of 8 4x minus 2 to the power of 3 dx. Okay, so our first step is to take the u here and define it as that variable. Okay, and then find du. Du dx equals 4, and then du equals 4 dx. Okay, not enough. We need 8 dx. So last time we had to divide. So this time we have to multiply to get the 8 dx that we want. Okay, so then we're going to multiply by 2 on both sides. So 2 du equals 8 dx. So we multiplied by 2 rather than divide, because why? Why did we do that? Well, it's because we want to eliminate this, right? 8 dx. We want an 8 dx. We only had 4 dx. How do you get from 4 to 8? You multiply by 2. Okay, so then we now rewrite it back into u form. Okay, so let's take a look at what that would look like. Okay, here we have 4 minus 2 to the power of 3. So 4 minus 2 is u to the power of 3. And then 8 dx actually is 2 du. So we have to write this as 2 du. So we're going to have to bring that 2 up front of the equation now. Get that constant in front so that we can just integrate. Okay, use the integration rule. So u to the 4th over 4 and plus c. Okay, simplify. Okay, 2 times u to the 4th over 4 is u to the 4th over 2. Y equals, I keep forgetting after we integrate, we should put the y in there. Okay, y is u to the 4th over 2 plus c. Okay, and then finally we put this back, this u back in terms of x. So y then would equal total of 4x minus 2 in brackets to the power of 4 over 2 plus the c, because we're doing definite integrals. Or if you want, you can write it as 1/2 times 4x minus 2 to the 4th plus c. That's correct too. Okay, so there's a manipulation where we're using an example of multiplication in there in our third example. Okay, we're about 19 minutes in, so I want to do a couple more examples yet. Sorry. Okay, so we've done one with division, we've done one with multiplication, and we've done just a basic one at the beginning. So let's do one with a root in it, like a square root or cube root or something like this. Okay, so let's do an example with roots. So in example 4, I'm going to do it with a root in it. With a root equation. Okay, rules are pretty similar. Okay, so let's go ahead and let's set up one with a root equation, which I have one here. X squared square root times the square root of 1 minus x cubed dx. Okay, so the first thing that we should do is we should do the same thing that we've normally done by finding use this as our u here, basically, and then finding out what du is. Okay, so let's go ahead and do that. U then would be equal to 1 minus x cubed. Okay, and then if we try to find du, so du dx, if we take the derivative of that, that is just equal to 3x squared. Okay, we can see that x squared dx is what we want. So if we solve for du here, we get multiplying dx on both sides, 3x squared dx. Not what we want. We want only x squared dx. So we're going to have to use a division to get it to of this to get it down to x squared dx. So we are going to go back to blue here and divide both sides by 3. So finally we have du over 3 is equal to x squared dx. So now we've done that, what we normally do, and then we're going to have to write the equation now in powers of u. So let's go up to here and do that. So if we take this part here, that is just going to be u to the 1/2. Okay, that's what this is. And then we've got, du over 3 is x squared dx. So du over 3. Okay, so we're going to do some manipulation there. I made a mistake, didn't I? I forgot this negative. This is a negative. It's negative 3x squared. So let's put some negatives in there. So this should have been a negative, and this should be a negative. Once we divide by negative 3, it becomes x squared dx. Okay? So this would be negative. My mistake, I've got to be careful there because of that negative when we take the derivative there. Okay, so good thing we caught that one. Okay, so now when we're doing this, we got to bring the 1 over negative 3 out front. So that we got u to the 1/2 du. Okay, so now we do integration rules. So that's adding. So we got 1 over negative 3, y equals. Okay, so now we got to add 1 to 1/2. So that's u to the 1, add 1 to 1/2 is 3/2 over 3/2 plus c. Okay, we have to do some simplification here. Okay, so this would be like, I'm going to do one simplification step at a time, so we're careful here. Okay, so I'm going to do this one first, and then I'm going to multiply the negative 1/3 so that we can figure out what we're doing. So this one here is divide by 3 over 2, which is the same as multiplying by 2 over 3. So that's going to be 2 over 3 u to the power of 3/2 plus c. Okay, now I can multiply this part out and get 2 over negative 9 u to the 3/2 plus c. Okay, that's complete to that point. Now we have to convert it back by putting this number back into here for u. So we got 2/9, which is negative. Okay, and we're going to multiply that by 1 minus x cubed to the power of 3/2 plus c. Okay, Okay, some books will write it as -2 times this, and then this all over 9. So it could be written like this. You might see it in this form. Same thing. Okay, so it could be written in either of those. Okay, we're at about 25 minutes. Okay, let's see here. I think, let me take a look at my list here. Let's just do one more with a negative exponent, okay, on the bottom. And then that should get through all the different kinds of examples that you're going to see in the practice work tomorrow. And of course, you won't have to do all the practice work that we had, but do probably, like, I'll make you do evens or odds. So let's do one more in the case here where we're going to do a negative, something on the bottom of a fraction. So this is our last example for today. Let's say we're going to end up with a negative exponent. Okay, so something like this. Okay, so let's say we had x to the 4th over the square root, of, what do I got here? X to the 5th plus 3. dx. Okay, so here we have something on the bottom here. So what we're going to do then is we're just going to write this as a negative exponent first. Okay, we're going to bring that up so that it's not, there's no weird rule or anything like that we have to worry about. Okay, again, I'm just going to pause quick here as I'm going to check that ding out, and then I'll be right back with you. Okay, sorry about that. So let's go through this one. Let's rewrite it here. I'll write it here. So if we rewrite this as a negative exponent, it's going to be x to the 4th bracket, this stuff here, x to the 5th plus 3 to the -1/2 power. Okay, it's 1/2 for the square root, and negative, we'll bring it back up here, dx. Okay, so let's go ahead and get our u. And then find du dx. Okay, and then du equals 5x to the 4th dx. Okay, so we see that in order to get x to the 4th by itself, we have to divide by 5 on both sides. Okay, and we're left with du over 5 equals x to the 4th dx. So that's what that is. So now we're going to rewrite it in terms of u. Okay, if we rewrite it in terms of u, we're going to go u to the -1/2 times du over 5. Okay, you can bring that 1/5 out front. Do your integral here. So y equals 1/5. Okay, so we're going to add 1. So that's u over 3/2. Or sorry, this is negative. Add 1, so it's going to be 1/2. Pardon me, almost forgot the negative in there. So that's going to be -1/2 plus 1 is +1/2. So 1/2. Okay, and then we have to put the 1/2 on the bottom here, times, or plus, pardon me, c. Okay, so if we're doing our, do this part first, this would be like multiplying by 2 over 1. So this would be 2/5 u to the 1/2 plus c. And then we can plug back into x. U or y equals 2/5 x to the 5th plus 3 to the 1/2 plus c. Okay, and that's our final example that I'm going to show you here in today. 5 different substitution types. We did one with negative exponents just here. We did one with where you have to use multiplication manipulation. We did some division manipulation. We did one with roots in it. And we did one with a negative exponent, which we just did here. And then we did just the basic one at the very, very beginning. Okay, so for tomorrow, let's go ahead and I'm going to just show you what the practice looks like for tomorrow. I'll bring it over. And then you're just going to work on your integration practice here. And this, so here's what it looks like. Chain rule says, I call it substitution or chain rule. Okay, here's, a few of them. I don't know, maybe I did some of these, I don't know. But I'm going to say don't have to do both columns of these. Maybe start on, this column here and work on the evens, or start on the odds and work on them. So, and make sure you're trying some various different kinds. Solutions are here. Okay, so work through, tomorrow you have a whole period. What you can get through in a period would be fine for practice work. Okay, and that's what you'll focus on day 5 is just that practice work. Today in day 4, we just went through that. And then on day 6, we'll get into definite integrals. Okay, all right, good luck. We'll see you. And just about getting to the end of integration here. It's a fairly short unit, so we're about halfway through.